Hi viewers, this is Dr. Gunamanjana and we are discussing about the object-oriented analysis and design in our fifth semester under this BPUT. In our module 1, we mainly focusing on these object models. This introduction to this object model, as you know, this object model, it is just a conceptual framework. This is used for understanding and designing the system in object-oriented environment or manner. Then when we go for modeling, what is the purpose? Why you go for model? Our main aim is to define the structure and behavior of the object. Before the actual development, actual construction, we make a small model so that before actually is manufactured or developed, we can understand its structure as well as the behavior. Then the object model serves as a blueprint for creating a software system by providing high level of abstractions. So hiding the low level details and all things, the important things we can also understand here in a real world entities and their interactions. This is the main thing or the main object of this object model. Then if you see the evolution of object oriented analysis and design, if you analyze and see between 1970 and 1980s, some object oriented software or the program they developed, hardly 10 to 15 softwares were developed, object oriented methods were developed. But between 1989 and 94, around 50 number of object oriented methods were developed. So you can see the drastically increasing things. And many users of these models had trouble finding a modeling languages that meet their needs completely, because some model is suitable for certain things, some other model is suitable for different things. They want one model, single model, which will meet to their needs. And thus fueling the so-called the method works. That means somebody has to develop a particular method for that one. Then some three important scientists in this area, like the Grady Booth and Jacobson and also Rambau. So Jacobson was working for this object-oriented software engineering, and Rambau for object modeling techniques (OMT). And Grady Booth, I think he was working there for this uh, rational group of people. So all they were working in three different models. So then a critical mass of idea started to form by 1990s when Grady Booth from this Rational Software Corporation, Jacobson from this Objectory, and Rambau from General Electronics, they began to adopt idea from each other's methods, which collectively were becoming recognized as the leading object-oriented methods worldwide. So what we are going to focus now, the same thing was developed by them that time. That's why these three people are called the father of all this object-oriented modeling. What we are doing it there, and what is the book they have written, UML using all things. So that is we treat it as the Bible till that. Then the very fundamental questions comes: why we model? Because when we model, we need a software. How to model? How to but we must know why to model. See, a successful software organizations is one that consistently deploys quality softwares that meets the needs of its users. Try to understand. It is not that one time do and throw it on others. It is consistently deploys quality software that meets the need of the end users who will be using that one. So an organization that can develop such software in a very timely and predictable fashion, they will be only successful. Then what other things we desire? It must be efficient and the effective use of these common resources, both human and the materials. These are the um, sustainable business. This is for the sustainable business. Then they can only sustain. Develop software of lasting quality. We have to craft a solid architectural foundations that's resilient to changes. Suppose you go for one or two changes, the software collapse or it don't work or malfunction. So it will not be successful. Then entire things I'm going to redo. That is not the wise. To develop software rapidly, efficiently and effectively with a minimum of software scrap and rework. We have to have the right people, the right tools, and the right focus. If three things are there, then only we'll be successful. To do all these consistently and predictably with an appreciation for the lifetime cost of the system, we must have a sound development process that can adapt to the changing needs of our business technology. Then comes the question of the modeling. So this modeling, it is a central part of all these activities that lead up to the deployment of good software. We build models to communicate the desired structure and behavior to our system. Then we build models to visualize and control the system's architecture. We also build model to better understand the system we are building, often exposing opportunities for simplifications and reuses. Okay. We also build models to manage the risk. Then we conclude like this: modeling is a proven and well accepted engineering technique. We build architectural model of houses and high rises to help their users visualize the final product. We may even build mathematical models in order to analyze the effects of winds or earthquakes on our building. All the things for this purpose we need modeling. Then we conclude a model is a simplification of reality, and we build models so that we can better understand the system we are developing. Through modeling, we achieve our aims. Then how the UML addresses these four things we discuss. First, modeling help us to visualize a system as it is or as we want it to be. Then models permit us to specify the structure or behavior of a system. Models gives us template that guides us in constructing a system. Then models document the decisions we have made. So for these are the reasons why you go for model. I request the learners to note it. So these are frequently asked questions in the university exam. Why we model? Again, we build models of complex systems because we cannot comprehend such a system as it is entirety. So we divide and make it small, small and make a model. In software, the models we choose can greatly affect our worldview. If we build a system through the eyes of a database developer, then we like focus on entity relationship model because the real world entity we call it as the object and the relation between them. This is the entity relationships model that push behavior into trigger and stored procedure. So this is the there if you see in the angle of a database engineer, not developer. If you build a system through the eyes of a structural analyst, try to understand, we like to end up with the models that are algorithm centric, with the data flowing from process to process. Again, if you build a system through the eyes of an object oriented developer, then we'll end up with a system whose architecture is centered around the sea of classes, okay, or the ocean of objects and the patterns. Okay, this we call it the design patterns. This is the procedures how to do of interactions that direct how these classes work together, right? So this is the need. Second, every model may be expressed at different level of precisions. Third, the best model are connected to the reality. Fourth, no single model is sufficient. Every non-trivial system is best approached through a small set of nearly independent models. So this is the things we try to understand. Then the software development takes an object-oriented perspective. And in this approach, the main building block is the object or a class. Simply, we put an object is a thing generally drawn from the vocabulary of the problem space in the solution space. The class is a description of a set of common objects. Try to understand. See, object is a thing generally drawn from the vocabulary of the problem space. Suppose problem space is just like no, is a vocabulary. So list of words or sentences like that. We pull some word from that one. I treated them as a, for example, I want to develop something a student information system or something like that. When I find there is a student, there is a course, there is a faculty, there is an institution, there is a department. So all the things I take it as the object or the classes. A class is a description of set of all common objects. Okay, when you say students, there are 2000 students in my class, in my department or institution. So the student at a student RIT students become a class, and CSC student of that particular. So like that, I can create the concept of a class or object. Every object has its identity. What is object? Object is a specific case of that one. Suppose I say student. Student means student will have a name, student will have a identity, student will have a date of birth, student will have a date of joining, he will be admitted to a course and he will be going for a program. All things are there. But while come to object, I say name is something like Rojalini Samantrai. Roll number like that, 24, like that. Roll number is 001. Something I'll say this is the email ID rosalini@gmail.com. So I say WhatsApp number 9876 dot 10 like that. So this is a specific case of that class student. For the class, name is required. I am writing for a class, name should be there. But what is the name in the class I have not given? For the class, I put it there. There will be registration number for the students, but that is not there in the class. So in this way, whatever things we want to do, that the specific cases are there in the objects. So I take just 1 minute break. So thank you. Now what I want to tell to you here. Sorry, it has taken big. Okay. So we are talking about these classes and object. So this object is a particular instance of that class that exactly I want to share with you. Then what are the key concepts of the object model? See, when you talk about object model, the first thing is the object, isn't it? The second thing is the class. Third thing is the attribute or the property, right? And the fourth thing is the methods or the functions. So if you come to analyze all the things, this object is the building block or the fundamental building block of all the object oriented systems. Then classes are these blueprints that define the common attributes and methods for the classes. Okay. Then are you following me what I'm telling you that if I say class is a blueprint. We make a drawing or we make something like that. We define. So for a student, there will be a name. For a student, there will be registration number. But while you come to object, the name is Ramesh, roll number is 501, and his phone number is something, email is something, his branch is computer science, is all things these are there. Then attribute, that is the just the the state or properties of that object. Okay. So what I'm telling you, that name, these are all the attributes. Then methods, the functions within a class that describes the behavior. Okay. So the first part is the structure, that is the attribute or the state, and the methods, that is the function. The students like to take a course, with a course. The student want to write the exam. Student need to go for some these things. These are things, the methods. Then here we come across what are the some of the object-oriented concepts we will be using here. We have the all things we already discussed about the encapsulation, the inheritance. Encapsulation is just bundling data and methods within a class, but hiding the internal states and providing controlled interfaces. That is the encapsulation. Simple thing. Bundling, putting together data and methods in a class. What is inheritance? It is a mechanism where a new class inherits attributes and methods from this existing class. All the methods and attributes there in the existing class. When I create a new class, just I inherits. So reuse is there. Okay, a lot of redundancy because same thing I will be repeating again and again. Redundancy will be there. So and also hierarchical relationships. Then we go for the polymorphism and relationships. Polymorphism, it is allows the objects of different classes to be treated as objects of a common superclass. Okay, and enabling different behaviors based on context. Poly means many, morphism form, it can take many forms. So this is the concept when used in there we call one of the things of this object oriented concepts. Then the relationships, you see relation is not father, mother, brother, sister. This is not the relationships. When define how classes interact or how the objects interact, then they cannot say, hello, class A, hi, class B, goodbye, so meet you again. Can they do it like that? Not like that. So there must be, because the classes cannot talk. Classes cannot no pass indication that I am leaving handshake, bye bye, goodbye, not like that. So they have to send some messages or say some symbols should be there. Through that we can understand, because these are all conceptuality, not that thing. So we go use some relations like association, aggregation, composition, dependency, and generalizations. See, you can say, what is this association class? You forget about the class and concept. I say an example of window in a wall. Say window is associated in a wall. Can you make a window standing outside the wall? So it is impractical. Say door is associated with a wall. Can you make a door stand outside in the air? So this is a, so that's why what are the things is part of that one, and without that it cannot. So there we use the relation association like aggregation. Aggregation, see, I will tell you, generalization, specialization, aggregation, and composition, dependency. These type of relationships we maintain, we will study in details. I think in this video it will be too long to discuss all these generalizations and specializations. Then the object and class, attribute methods, all things we discussed. Then the encapsulations and data integrity. Uh, Encapsulations ensures data integrity by hiding the internal states. I think these are the things we already covered. Polymorphism flexibility. So then we are going for this second part of this thing, this classification and abstraction. In the classification and abstractions, we are going for identifying the candidate classes. So we do by the domain analysis, begin with a thorough understanding of the problem domain. How? By studying requirements and use cases to gain insights into the system's functionality and constraints. See, before we develop a software, because we mainly focusing on the software developing, not I am not going for the manufacturing, or not I am going for this developing some things, physical things. Then what we do? Suppose I am a developer and somebody, you are the end user. You want to purchase a software, or you want me to develop a software for you. Then what you do? Is it that everything is available with me? You come and pay money and take it? No. So we conduct a meeting, sir. We want a software for the student information system. So these are things we expect in that software. Mm. Then I listen all the things. My people listens, they note it, they go for the documentations, and show you these are things desired from you. So in addition to this, I will giving you some other features. But this is the things it is desired by you based on the things we are going to design. So I make a documentations. I keep a copy with me and I give a copy to you. Both we sign and agree. Then the part starts, execution part starts. Then what happens here? Whatever the documentations or the scenarios, whatever things we recorded, we have taken. With the documentations, I come back to my design team and tell, oh, we are going to develop for Roland Institute of Technology software for this thing and things. Then what is the thing start? Then my work starts how to show them graphically or diagrammatically that how the system works and all things. Then I start doing, okay, so I have to show some use case diagrams or some class diagrams. From this they can understand how things flowing, what is happening there. Then I have to find the use cases, I have to find the actors. Then there is a hand rule. I try to find the noun and noun phrases, identify the potential classes and objects by recognizing noun and noun phrases in the problem statements and requirements. Okay, so this is the problem statement and this is my requirement. From both the things, I can find out what is the noun and noun phrases, right? Then refining and validation classes. So then we define the responsibilities, determine the responsibilities of each candidate class, including attributes, its methods or operations, refining the validating classes based on feedback. So all the things we take care at the initial level. Then establish a relationship, identify how classes interact with each other through this association or inheritance and dependencies, all these coherent and other things, right? So these are the things the developer team they try to understand. Once they understand, they start working. Okay. Then section 3, the modeling techniques in the OAD. One is the basic modeling techniques, that is the class diagrams. Okay, then is the interaction overview diagrams. What is this class diagram? So describe the static structure. Which one? The class diagram describes the static structure of a system by showing its classes, attributes, operations, and relationships, and essential for understanding. These all things are essential for understanding the system architecture. If you try to understand the system architecture, we have to use this class diagram. Then interaction or overview diagrams. This provide an interview. Sorry. This provides an overview of the flow of control representing interactions and decisions in the system's workflow. So these are the things we call it the interaction, right? Then advanced the previous what you studied, the basic modeling techniques or BMT. This is the AMT or the advanced modeling techniques. So the state machine diagram, state chart diagram, activity diagram, all things are coming under that one. What the state machine diagram does, it describes the states of an object and the transition between these states, starting from one state to another state. This is the transition, by addressing complex scenarios and improving the robustness of the system. Then what is this activity diagram? This model the workflow or business process in a system and depicting activities, transitions, decisions, and the merge nodes. Right. So these are things we come across. Then I think we will go for one more video where we'll be going for the introducing the UML and what are the overview of this UML. Okay. So these things we will take one more video to explain all things. Thank you for watching this video. And if you like this video, please do share with your friends, and also you can give your comments or feedback. Once again, thank you and have a good health, good time. Thank you.